Here is the solution to exercise 36 of chapter 1.2 of Adam's book. The whole thing is on this board, but I will talk you through each step. We're supposed to compute the limit x goes to 0 of this fraction with absolute values in the denominator. If I just plug in 0, I get absolute value of -1 minus absolute value of 1. That is 0 divided by 0. That is no good. I don't know what that is doing. Does the numerator go faster to 0 than the denominator? Does the numerator go faster to 0 or slower than the denominator? Or do they somehow just at the same speed? And we actually get a real number as a limit. I can't even say whether it exists or doesn't exist if I just look at this like this. So let's rearrange things. In the first step, we multiply the numerator as well as the denominator with the sum of these two absolute values. And this might look a bit like magic. How do we know that this is a good idea? This is the trick that I told you on Friday, namely, this is what you see on top of the board in the box where I wrote 2. This is the third binomial formula, a plus b times a minus b equals a squared minus b squared. And usually we want to go from the right to the left, factoring a squared minus b squared to then be able to get rid of one of the factors that we obtain. But here we do it the other way around. Here we start with a minus b, so the a is the absolute value of 3x minus 1, and the b is the absolute value 3x plus 1. And we multiply everything with the a plus b such that we get absolute value of 3x minus 1 squared minus absolute value of 3x plus 1 squared. And that is the next step that I wrote down. This is why there is a 2 in the box of the third binomial formula. Now we can drop the absolute values because absolute value of x squared is the same as x squared. That is what you see as the third step in the calculation. Why is that? Here I added, after taking the photo, the definition we had of the absolute value of x. So if x is positive, then this is x. Well, in that case, the square of the absolute value of x would just be the square of x. And if x is negative, then the absolute value gives us minus x. So the square of the absolute value of x would be the square of minus x, which is minus times minus is plus, and x squared. And x squared is again left. You can also see that if you know that absolute value of x equals the square root of x squared, that is sometimes useful. And then you can see that the absolute value of x squared equals x squared very quickly by writing down what you see in the box with the 3 on the right of the board. Absolute value of x squared is replace the absolute value of x by square root of x squared, and then that's still squared, gives x squared since the outer square and the square root cancel out. Be careful, the inner square and the square root do not cancel out because there we would have a solution plus minus x squared. But if we square at the end, everything will be positive. So no need to keep the absolute value in whatever is underneath the square. Okay, that was the explanation for the third equation sign. And now we have a really nice numerator, which gives minus 12x. And we can cancel the x with the x factor and the denominator. And we still have the absolute values here, but now we don't mind, because now we have a plus between the two absolute values and we can simply put in 0. Remember, we wanted to compute the limit x towards 0. So absolute value of 3 times 0 minus 1 is absolute value of minus 1, that is 1, plus absolute value of 3 times 0 plus 1, absolute value of 1 equals 1. Simplifying, minus 12 divided by 2 gives minus 6. And that is the answer.